Hello everyone, my name is Vipra Joshi and I am an assistant professor in St. Andrews Institute of Technology and Management in Electrical Engineering Department. I am going to deliver a lecture on subject of basic electrical engineering. In this video, we will discuss on superposition theorem. This is Unit 1 topic of second semester in engineering. Superposition theorem. It is one of the most important theorem that we use in electrical and electronic circuit. Statement of superposition theorem is the current through and voltage across any element in a linear bilateral network equal to the algebraic sum of all the current or voltage produces independently by each source. So you have to consider whenever you have problem in superposition theorem, you have to list out how many sources are there. It may be voltage source or current source. Whenever you are analyzing a problem by using superposition theorem, you make sure that how many number of sources are given. You have to consider one source at a one time and replacing remaining source with their internal impedance. The superposition theorem is very helpful in determining the voltage source across the element or current through the branch when the circuit contains multiple number of voltage and current source. Superposition theorem. In order to apply superposition theorem to a network, certain conditions must be met. First, all the components must be linear. It means property of all components should be linear. For example, the voltage on resistance is proportional to the current, and for inductor, the flux linkage is proportional to the current. Second is all the components must be bilateral. It means for every opposite polarity voltage, the current flowing through it, we can say the amount of current will be same. And third is passive components may be used. These are components such as resistor, capacitor and inductor that do not amplify or rectify. And fourth is active component may not be used. Active component include transistor, semiconductor diode or electron tube. Procedure for applying superposition theorem. Consider only one source to the active at one time. Remove all other idle voltage source by short circuit and all the other idle current source by open circuit. So here we need to define if there is voltage source and how we are going to consider it, and same for the current source. Whenever you replace a voltage source with an internal impedance, it should be short circuited like that. The voltage source will be short circuited, and whenever there is a current source is given, it is open circuited like. If there are practical source, replace them by the combination of ideal source and an internal resistance. After that, short circuit the ideal voltage source and open circuit the ideal current source. In this figure, this is voltage source and this is the internal resistance. So, if we consider current source, then this voltage source become short circuited like this. And for the current source, if we consider the other source, then the current source should be open circuited like that. By this we calculate superposition theorem and we calculate the current flowing through the all branch by the all independent source. Now we will discuss an example on superposition theorem. Using the superposition theorem, determine the voltage drop and current across the resistance 3.3 kilo ohm as shown in figure. So first we remove the 8 volt voltage because at one time we consider only one voltage source. The first voltage source is 8 volt and second is 5 volt. So if we consider 8 voltage source, we remove if we consider 5 voltage source, then it is necessary to remove 8 voltage source, means it is short circuited according to the superposition theorem. So remove the 8 voltage power supply from the original circuit such that new circuit become as following the same. Then measure voltage across the resistance. Here we are. For this we have to calculate the total resistance across here. We can see that the 2 kilo ohm resistance and 3.3 kilo ohm resistance are in parallel. So we calculate this resistance in parallel. We know that in parallel, if there is two resistance R1 and R2, the formula is R1 into R2 upon R1 plus R2. So by this we calculate the total resistance across this is 1.245 kilo ohm. Using voltage divider rule, voltage across 1.245 will be In this figure, if we apply voltage divider rule, we know that in voltage divider rule, here if we find VR across the parallel ohm resistance, so the parallel resistance RP into main voltage source means 5 voltage source upon the series resistance 4.7 kilo ohm plus RP. So the value is V1 equal to 1.245. It is parallel resistance upon parallel resistance plus series resistance with this resistance into 5 voltage source. According to voltage divider rule, the voltage is divided between two series resistor is directly proportional to their resistance. So, if we find voltage for particular resistance, so if we find voltage for resistance R, then here we use this resistance into main source voltage upon resistance plus the resistance across this branch with series. So after applying this rule, we find the value of V1 is 1.047 volt. Now step 2 is, at first we consider 5 volt source and the 8 volt source is short circuited. Now we consider 8 volt source and 5 volt source is short circuited. By this figure become like that. Now if we apply, here we find the resistance across 3.3 kilo ohm and 7.7 kilo ohm. Here two resistance are in parallel. So if we calculate these resistance, the value our resistance will be 1.938 kilo ohm. Using voltage divider rule for this branch. So here if we apply the voltage divider rule, then the value of VR equal to the parallel resistance across 3.3 kilo ohm and 7.7 kilo ohm parallel resistance here multiply by 8 volt source upon parallel resistance plus resistance with this in series means 2.0 kilo ohm. By solving it, we find the value for that 3.9377 volt. Therefore, if we consider the first voltage source, when we consider 5 voltage source, there we find voltage V1, and for 8 voltage source we find the value of voltage V2. So the total voltage drop in the 3.3 kilo ohm resistance is V1 plus V2. It is 1.047 plus 3.9377 equal to, if we add both values, it will 4.9847 volt. I think you are understanding the topic better now. What is the step for superposition theorem? Consider only one source at one time in first step, and then in the second step we remove all the voltage source, means ideal voltage source, with their internal impedance. It means we remove all the voltage source by short circuited and all the current source by open circuited, except only one source which we have to consider. After that, we find voltage or current by the particular circuit. So, if we have the value I1, I2 and I3, or we can say V1, V2 or V3 by the source A1, A2 and A3, which can be voltage source or current source, then the total current become IT equal to I1 plus I2 and I3. It is the total current by the superposition theorem. This current is flowing by the all sources, and it is same for voltage source. If there is V1, V2 and V3 voltage by the source A1, A2 and A3 respectively, then the total voltage is Vt equal to V1, V2 plus V3. So this voltage is the total voltage by all these sources. I hope you have understood the topic. Thank you.